Welcome to the GroundBreakers podcast, where each episode we dive deep with the brightest minds in tech to channel the thoughts and discover new insights. This podcast is brought to you by Shorooq, the leading tech alternative investments manager in the Middle East and North Africa. And I'm your host, Tarek Fouad. If you are new to our channel, please do join our community. Don't forget to leave a like, subscribe, and hit that bell icon to stay updated with our latest episodes and news. Your support helps us in continue creating valuable content for founders and investors everywhere. Today, I'm excited to have Eric Siegel, a former Columbia University professor who helps companies deploy machine learning. He is the co-founder and CEO of Gooder AI, the founder of the long-running Machine Learning Week conference series and Generative AI Applications Summit, the instructor of the acclaimed online course Machine Learning Leadership and Practice End-to-End Mastery, executive editor of the Machine Learning Times, and the author of the best-selling Predictive Analytics, The Power to Predict Who Will Click, Buy, Lie, or Die, and the AI Playbook, Mastering the Rare Art of Machine Learning Deployment. His books are considered a reference and has been used in courses at hundreds of universities. It's a pleasure having you, Eric.
Thanks, Tarek. It's great to be here.
Now, I want to kind of start at the beginnings. I think your passion for AI has begun since your childhood and has spanned over 3 decades. How has your kind of early fascination for everybody who doesn't necessarily know Eric today shaped the way that you approach machine learning?
Well, I've been in the field of machine learning for more than 30 years, pretty much since the beginning of graduate school. I got my PhD at Columbia University, where I was then subsequently on the faculty. And at the time, I was sort of like, I'd say most data scientists operate this way. You fall in love with the idea of machine learning abstractly because it's the coolest kind of science or technology. Learning from data to predict is an amazing thing. Ascertaining patterns or insights, formulas from some limited set of examples, typically historical examples, that then turn out to work, to pertain in new unseen situations. That is to say, it's actually learned something that holds true over the world, not just existent in previous examples, but that it is in that sense true. That's like really, really cool. It's philosophically interesting. It's technologically challenging, but surmountable. It's proven, it's concrete, and it has very concrete use cases in the business world and across industry sectors. So the combination between how cool it is and how potentially valuable it is means, hey, this is exciting. We love this technology. And I think most data scientists kind of go through that. In more recent years, I've been seeing that these projects fail. So most predictive models generated with machine learning with the intent to be deployed, most of those new projects actually fail to achieve deployment. By deployment, that means actually acting on the predictions that are output by the model that was generated from data. So data is used to learn the model, train the model, and then the model is used to generate predictions. But those predictions are only useful if you act on them. And that's deployment, operationalization, going to production, actually getting it out there so that it's, your organization's operations can't improve unless they change. And that's what it means to integrate, to act on those predictions and drive operations more effectively. But that's change. That's business change. It's a lot more than just the number crunching. So in a sense, the world kind of fell in love. Well, the world, not just the data scientists, but also the way it's represented and sort of marketed it to less technical world at large. It's also, in a sense, fetishizing the core technology. So the world kind of fell in love with this, not to mention the narrative around the term AI, which is not well defined, but often just refers to machine learning. So excited. It's like being more excited about the rocket science rather than the launch of the rocket. It's high time that we make a change so that these rockets actually get launched, that these projects actually follow through and get to that point of deployment at a much higher success rate than currently. Currently, it's kind of a dismal success rate, but there's no reason it needs to be that way. It's an organizational challenge more than a technical challenge. And that's the purpose of my new book, the AI Playbook, is to address that and say, hey, look, here's the very particular customized, specialized practice playbook framework that we need to follow as organizations if we're going to get these projects not only to succeed technically with the number crunching, but to also deploy.
I love that. We'll actually speak a little bit more about what you discuss in your book in a while. And I want to shift gears, and it's such a great segue to kind of talking about generative versus predictive AI. In your talks, you've differentiated sharply between both. Can you kind of elaborate more on the unique value predictive AI still holds in today's kind of tech landscape? And what are some of the untapped opportunities within predictive AI that businesses today are?
So predictive AI is probably the new term. From what I've seen, that's the new term that's being adopted for what was previously called predictive analytics or enterprise machine learning, right? So prediction is the holy grail for improving large-scale operations. Operations consist of many decisions, and each decision is driven by prediction. Will you buy if I contact you? Then contact you. Will this transaction turn out to be fraudulent? Then audit or block the transaction. Will this train wheel break? Will this satellite run out of battery? Should I drill for oil here? You know, most of our main, and in healthcare, most of our main large-scale operations consist of decisions that would be improved by putting a probability on the chances of a positive or negative outcome or behavior. So those use cases of machine learning are established. They've been going on for decades. Most of these new initiatives fail, but many succeed. Even if it's only 20% of lots of projects, that's lots of success. And so that's sort of established, and that's what everybody was mostly referring to when they said AI until generative. Generative AI is just another way to use machine learning. So in this case, the predictions are on the per word level, or not exact, it's per token, but it's on that level of detail. I've written this paragraph and a half, or I being the computer, what should the next word be? Okay, let's write that. Now do it again. You do that one word at a time. In the case of generating images, we're in the middle of rendering this image. What change to this pixel in this context would be the next best thing predictively for continuing to iteratively create the image? So when you apply machine learning in that way, the results are dumbfounding. It's unprecedented. It's something I never thought I'd see in my lifetime, both in terms of image generation, human language generation, like English and other languages, and video and sound, music. So the difference between generative and predictive is really about how you're using machine learning. They're categories of use cases. The words refer more to how you're using it than to the particular technology. Although certainly for these different uses, you have different slants on the technology, but they both fall under the umbrella of machine learning, which is learning from data to predict. Yeah. In the case of large language models, the data from which you're learning is sort of everything that's ever been written, right? So we know you take any web page or any page of a book, and you can just break it into many, many individual learning examples, because you just cut it off after a certain point. You're like, well, they wrote this paragraph and a half or these pages up to the middle of this sentence, and then here's what the next word turned out to be. That's an example from which to learn. Just as the same in those enterprise use cases of predictive. This customer, we knew these things about them, and then they turned out to cancel their subscription, right? So you have these examples from which to learn. It's just you're operating on a different way, very different level. The two areas should not be a zero-sum game. They solve very different organizational problems. They provide value in very different ways. They should compete no more than water parks and ski resorts. But in reality, it is something of a zero-sum game, because generative is such an amazing, shiny new object and is so seemingly human-like and impressive to a dumbfounding degree. Then the AI narratives that sort of imply that it's going to be autonomous, perhaps in a way that it never will be or won't be in any time soon. You put those things together, and this shiny new object sucks all the oxygen out of the room. So much to the detriment. I would say that organizations, it depends on the organization, but in general, should be putting energy and focusing on predictive use cases at least as much as generative. Predictive is where you turn to improve your existing large-scale operations, and where you do benefit from the autonomy the computers offer. The whole point of making any kind of machine, including computers, is to automate something that we would have to do by hand. If you've got it making predictions about which transactions are likely to be fraudulent, in most of these use cases, no, it does not predict perfectly like a magic crystal ball, but predicting better than guessing is sufficient to drive value. And so we're decreasing the amount of errors. You can have it automatically deciding which credit card transactions should be approved or which should be held as potentially fraudulent. Whereas with generative, if I were to try to characterize the difference between what's, just because it's amazing doesn't mean it's valuable. It is valuable for certain very well-defined use cases. And that set of use cases will continue to expand and the capabilities will continue to improve. But there's a narrative out there that's sort of implying a level of autonomy of human level capabilities that I do not believe we're approaching. So it's a little abstract, but I would say, hey, look, you need to be the antidote to hype is to focus on concrete use cases and value propositions. And we need to be very careful that we're not investing a lot into a pipe dream that basically implies artificial humans or a level of autonomy like you can onboard a human employee. So there's a certain fanaticism around it that's going to hurt us because it's going to backfire, right? There's going to be disillusionment. That is to say, it's hype.
Yeah, I think this goes back to the concerns that you've raised and expressed about the hype around and surrounding AI, particularly generative models. And I think you've touched upon how companies should navigate the potential and the pitfalls of adopting these different models and specifically for use cases. Can you probably give us an example of a hype-driven AI project that you've seen in your experience failed due to kind of misalignment in expectations and how it could have been approached differently?
Well, I mean, as far as places where things fail because of hype, that's sort of the hidden story of AI in general. I mean, as I mentioned, in the case of predictive cases where I've participated in conducting industry research, a couple rounds of that with surveys. And my work there, as well as that of others, is very much showing that most of these projects fail to deploy. And I believe that a big part of that is essentially hype, where the business stakeholder, the decision maker, sort of greenlights the project on a wave of excitement, but is sort of overly delegating everything to the data scientist, as if the technology is intrinsically valuable. And as cool as it is, learning from data to predict, it's not intrinsically valuable. The value only comes when you act on it, when you deploy it. And the only way that's going to happen is for the stakeholder to be involved in some of the nitty-gritty details by not getting their hands dirty in that respect, by not getting involved in semi-technical details. Their feet will get cold. So non-dirty hands, cold feet. And then at the end, they balk at the idea of changing their existing large-scale operations that are so vital and important, unless they're involved step by step along the way. But as far as generative, I don't know, it's early, and in general, failed case studies, don't see the light of public. And in general, the world's quite adept at sweeping failures under the rug and spinning it and such. But I would say that the investment in all things generative AI, it puts a valuation at least an order of magnitude higher than it should be.
Yeah, I hear you. I think eventually a lot of these models as well will kind of output very similar results in a degree. It really boils down to application and use case and going deeper into the use cases rather than creating generative AI models in a sense.
It's got to be how you're going to use this, right? Right. And there are a very small but growing number of public examples where companies did a study, right? They had a very particular way of using, let's say, a large language model, and then they studied the improvement to efficiencies. And you see improvement to efficiencies between 30, 50, maybe 60% as far as improving the time needed for humans to generate marketing content, or for customer service agents operating on a chat to provide service, and how many tickets they can get done per hour. So you got to focus on that value commit to exactly how you're going to measure it, what metrics matter, and then follow through, actually measure it.
What are some of the common barriers that you see organizations trying to put AI into operation? And I think you mentioned one on kind of the leaders work around the hype, but they don't necessarily put the right resources to play.
Right. I mean, the hype is certainly a major component or factor on some level where they're just like, this stuff's awesome. It's the best thing since sliced bread. It's the most advanced kind of technology. We have the best expert. Therefore, let them go at it. They know what they're doing. But it's not a technical project. It has to be an operations improvement project that uses this technology. So the disconnect comes, it's ultimately sort of a lack of planning for that final step, which is actually changing operations, the actual deployment. So one key component of that is understanding how good is it? What are the metrics that matter? How are we measuring it? And typically the data scientist comes along and says, look, I made the model to predict which transactions are fraudulent. This should do a much better job triaging for your fraud audit team. And then the stakeholder says, oh, well, that's interesting. How good is the model? And the data scientist says, let me clear my throat here. The data scientist says, well, the area under the receiver operating characteristic curve is 0.83. Isn't that awesome? And then stakeholders like, it sounds pretty awesome. What does that mean? What does that mean in terms of the actual cost savings when I consider the cost of fraud not getting captured and the cost of my audit team who are inspecting? How much is it going to change the bottom line? In very straightforward KPIs, the lingua franca of business, the thing that matters for the organizational strategy and that matters to me as a business stakeholder and decision maker. Data scientists can't answer that question in general. The rare exceptions, they might hack together some estimate, but it's not very dynamic. So what I'm actually queuing up here is that's what we do at Gooder AI. We have a product for not just evaluating, but valuating, saying what's the business value of this model depending on how you deploy it, so that we can make sure we're navigating the development of the model towards business value, not just technical perfection, because technical perfection is the MO of the data science community up to now. Right? That's how these things are taught. That's the courses in the books. It's all about improving technical performance, which relates very little to the actual estimation of the potential business value. Whereas what we want to know is profit or savings. What's going to be delivered to the business if we deploy this model, depending on how we deploy it, and depending on a few other pivotal assumptions that may be subject to change or uncertainty. So the only way to do that is to have an interactive what if visual where you can try those what if scenarios and try changing certain things about the deployment. Like, am I gonna audit the top 2% of transactions that it might be fraudulent, the top 3%, the top 0.5%? Decisions like that actually are pragmatic and where you need the stakeholder to understand and be involved in the detail of how you're going to actually deploy the model. If we don't get their hands dirty, their feet will get cold. They've got to be involved end to end. So my book is about the general framework of a 6-step practice for running the project that needs that business involvement. But in terms of the actual metrics, that's where there's an opportunity out there for a new type of software to handle that. And that's what we're doing at Gooder AI.
I love that. I will touch upon the AI Playbook, but I want to remind everybody who's listening, we're linking the Gooder AI website and Eric's website in the description below. So please do go check it out for yourself. If you're an organization looking for Eric's help, this is a great place to start. Eric, it's great that you're bringing about the AI Playbook, because that was literally my next question for you. You do outline that 6-step process for AI project deployment. Can you discuss why a structured approach is kind of crucial and what steps is most often mishandled as you've worked around hundreds of organizations helping them? Probably give us insights on where do most people miss out on.
Well, we need to plan in reverse. We need to plan for that deployment. It shouldn't be, we need to reframe the project so it's not just a machine learning project, but it's an operations improvement project that uses machine learning pivotally. So there's that reverse planning plan for the end, and there's sort of breaking down what that consists of across a series of steps in a way that the business stakeholder understands and can be involved with a certain degree of detail end to end across all those steps. Those are pivotal. So the broader theme is that more than anything, these projects don't need better technology or better data scientists. They need, if you're not a data scientist, if you're the stakeholder, they need you. After you've ramped up on a very accessible, interesting, semi-technical understanding, basically, it's not a 45-minute pod episode, but I'll outline it now. But it's a book's worth, and that's really the purpose of the book, is to ramp up that business reader on what's semi-technical. And the semi-technical understanding simply comes down to what's predicted, how well, and what's done about it. What's predicted and what's done about it, that pair defines the use case, the value proposition, and there's so many things. Who's going to buy, then market to them, which transaction is fraudulent, then audit it, which component's going to break down, then inspect it or replace it proactively. In healthcare, across industry sectors, that pair, what do you predict and what do you do about it? There's so many pairs. I see new ways that machine learning is being applied in that respect, a couple times a month for 30 years. Wow. It's just so generally applicable. As the Harvard Business Review put it, machine learning is the most important general purpose technology of the century. Great. But of course, it's not only valuable if you actually get that second part, what's predicted and what's done about it, do something about it, actually get it deployed. So the semi-technical understanding are those two, and then how good is it? The metrics, as I was mentioning, not just the technical performance, but also the potential business value in terms of profit or savings or other business metrics. So getting involved, and that's just arithmetic. It's not the rocket science part, but it's very particular arithmetic. So getting involved in those, in the mechanics of what does it mean? The thing's going to make a prediction that is a probability, a number between 0 and 100 of whatever the thing you're trying to predict, the outcome or behavior for this project. And then how are you going to act on it? How are you going to use that to make a difference in the operations? Those mechanics, again, not the rocket science. It's a business decision. It's an operational decision. And that level of detail must be informed by a decision maker who weighs in from an informed standpoint. So they need to understand some of it and be involved end to end of the project, or at the end, you'll pass on the model and they'll drop the pass. They won't be ready for it. They'll balk at the notion without fully understanding, okay, I know it's not a magic crystal ball. It predicts better than guessing. That's potentially valuable. How much more valuable? Why does it deliver value? How do I get this? It's not the rocket science part, is the learning from data, which is also worth getting involved in, get a little knowledge. I know the general idea of internal combustion, although I don't know anything else about my car engine. I can drive the car, but I'm an expert in driving cars, right? Just like you are. I know momentum and friction, the rules of the road, and the way the car operates, and the mutual expectations of drivers. Analogously, you need that level of expertise to drive a machine learning project through to successful deployment. So having said all that, the 6 steps almost write themselves. The first 3 pertain to those 3 aspects that I said: what's predicted, how well, and what's done about it. Not really in that order. So the first is to define the deployment goal. Your reverse planning. You're planning the culminating step of deployment in the first. So you're saying what's predicted and what's done about it. Let's define the use case. Let's get all on the same page. Now, it turns out that when you do that, you got to get really, really specific about the prediction goal, which data scientists know as the dependent variable. So you're not just predicting who's going to buy if I market. You're predicting who among my customers who've already been around for 3 years and spend this much on average, how many of them are going to spend at least this much, not including shipping above the margin, within 3 months of receiving this contact, and not return it for a discount within another month after that, et cetera. So all the caveats and qualifiers, right? It's not the rocket science, and it's not super technical, but it can end up being something, can be easily 3 times as many as the example I just spouted out. Getting involved in that level of detail to define exactly what behavior we're trying to put odds on with this model, because it's very pragmatic. If you're going to drive an operation with that prediction of what exactly, and that turns, so I've separated that out. That's step 2 out of 6. And then the third has to do with the metrics. What are the technical and business metrics like profit and savings, and what level do they need to achieve that we're going to measure and estimate in terms of the potential value and performance of this model? so that we can green light its deployment. Let's get on the same page. Those first 3 steps basically represent pre-production planning phases that need to involve business stakeholders. The other 3 steps are the actual production, and these are intrinsic. This is, every data scientist knows this. All projects since the 1960s, when we first started using machine learning and regression or whatever for targeting credit decisions and marketing, follow these 3 steps, which is to prepare the training data, train the model, and then deploy it. Now, having said that, we're culminating with deployment. That's what so often is unachieved. After that, you need to continue to monitor and refresh the model. But in terms of just formalizing this, most business stakeholders out there don't really yet know that you need very much a very particular specialized type of playbook practice paradigm along the lines of the one I just outlined, let alone any one particular, which is why we're trying to brand this nicely. So the buzzword is BizML, the business practice for running machine learning projects. And bizml.com is the website for the book.
Love that. I want to shift gears a little bit, Eric, here and talk about ethics and social justice. I actually found this quite interesting. And you've also written about analytics and social justice. How can AI be leveraged to kind of promote social good without exacerbating the existing inequalities?
Well, staying on these kind of predictive use cases, predictive analytics, predictive AI, there seems to be a little battle out there of what we should be calling it. But I think predictive AI will take off because we got to differentiate it from generative. And that's obviously a big term these days. I've written a bunch of op-eds in this area and some videos that you can find all together in one place at civilrightsdata.com, just for ease of access. But basically, when you're running these projects, you're not just number crunching and streamlining business, you're essentially governing, because the model that's driving these decisions actually dictates access to resources and privileges, such as whether you get approved for credit, whether you get housing, whether you receive information about via marketing about an opportunity, and even liberty from incarceration, where these models are predictions are being used by judges and parole boards to decide on sentencing or whether you're up for parole, released on parole from prison. So you can think of the model that puts a probability on the risk of a negative outcome, which in turn drives these decisions. And even if it's done only semi-automatically, even if it's a human making these decisions, which is true for some of these projects, there'll certainly be cases where the probability they got from a model is the deciding factor. So you can think of the model as a policy in a sense, because it's taking aspects of you and the current situation and making a determination of what risk level you belong to. Will you pay back this debt if we grant your application for credit and what have you? So the main social justice issue that comes up is where you see a difference in false positive rates between protected groups. So members of a different race, nationality, ethnicity, et cetera, it'll turn out have a higher propensity of false positives, which is when basically the model says you're high risk undeservingly, right? The model is going to make mistakes just like humans do. The question is, the social justice question is, does it make those costly, life-changing mistakes for people of one category more than another? That's a big problem. So that's usually referred to as machine bias. There's a ProPublica article with the title Machine Bias, which sort of is a main source of reference whenever people talk about that. It gets pretty technical pretty quickly. So that's some of the stuff I've done, is writing more for lay people, breaking it down, and also providing videos with some visuals to help break it down. But I also have an opinion about it too, which is that I think that we should avoid that. I think that we should equalize the false positive rates.
I have two follow-up questions because, I mean, social justice did not necessarily come to me right off the bat as a place for AI to be used in. And hence why I was actually quite interested in exploring this a little bit more. And I think my questions are, one, are there sectors today that lend themselves better to predictive AI and applications of AI more than others? And two, what measures should AI developers take to ensure their models do not perpetuate bias or harm?
Sure. The thing that makes the biggest difference isn't the sector or the size of the organization, but it's the size of the operations. So even if you're a small company, but you're sending 1 million brochures every holiday season as a gift catalog, you've got a bunch of experience from which to learn as far as who responded in the past, and you have a relatively large scale operation that stands to improve. Now, I'd say that the most advanced sectors tend to be high tech, financial services, maybe a few others, but it really, after that, really varies from one company to the next. So it depends on the culture of the company and the development, the history of the company, and the current staff. So any large scale operations, or most any, stands to improve. So the place to, if you haven't started using it, the place to look for your lowest hanging fruit is what's a large scale operation where predictions could potentially help improve operational effectiveness. And then at the same time, of course, these ethical issues are important. They're worthy. They're not, I think that they are the opposite of painful to look into. I mean, there's a level of pain because it's tough because historical injustices are now being inadvertently perpetuated, and that's the nature because data reflects today's world, which reflects history. But it's also, if you care about other people, it very quickly becomes interesting, right? And you're kind of like, oh, how do we solve this? How is this happening passively? And what do we have to do proactively? But it also depends on what decisions you're driving, right? If I'm trying to decide whether to recommend onions and peppers as a topping on your pizza versus pineapple as a topping on your pizza, I don't know if there's going to be a big ethical concern about, if it turns out I'm representing my system for some reason is recommending pineapple to women more than men or something like that. What matters is where you're using it to drive a consequential decision that really can potentially affect the life of the person that about whom you're deciding a treatment, right? Treatment is an abstract term and it applies for healthcare. And these issues come up in healthcare as well. And I've spoken on them in a couple of healthcare conferences. But treatment also is just any operation, like should I contact them for marketing? Should I approve their transaction or their application for credit, what have you? So treatment, just abstractly, that's what you're doing. You're driving a decision, often a human-facing decision with the analytics. So it's worthwhile, if it's a consequential decision that you're driving, it's worthwhile to do this analysis, and which inevitably means reintroduce. So if your model is blind to protected class, which in general they are, right? It's not basing a decision explicitly on the protected category of the person. It's still, as a consequence of sort of surrogate variables and the nature of the world, it's still potentially going to have that type of bias and defined in that way. And you can test for it. But of course, that study requires reintroducing the protected class into the study itself to get a sense of the difference in performance.
Got you. And how do you see the role of AI kind of evolving in the next decade, particularly in how organizations learn? Will it change with AI? How do we evolve our approach to kind of thinking about learning in general? Will this mean, for example, that our on-the-job learning will probably look a bit different in the future?
So that, like a lot of questions about the field, the answers are so different if I'm thinking about predictive use cases versus generative, just completely different worlds. So in the case of predictive, this is how I would put it. Today, the way that those use cases are pursued is post hoc. So you've got the business, it's already going along, operations, large scale operations that generate data as a byproduct. Transactions get logged. And that turns out that was the big data movement, to say, hey, this data is really valuable. It's experience from which to learn. and it's being collected almost as a side effect, like the residue of doing business as usual. Which means that it can be kind of messy. It's kind of a post hoc project where you're like, well, let's try to take this stuff that we've accumulated and rejigger it so that it can be valuable. That of the 6 steps, step 4 was the data preparation. And the reason that has to be a whole step is you need to put together something that's sort of clean and coherent for the actual rocket science part, the model training. You have to have a bunch of positive and negative examples of the thing you're trying to predict. And each one could be like a picture, and does this radiology image convey a positive diagnosis, or it could be a several dozen pieces of information about a transaction and then whether it turned out to be fraudulent. So there are examples from which to learn, but the way your data happens to look right now across silos, across data tables, typically it's a very specialized database programming process to clean it up. And it turns out to be hairy, right? It turns out to be by far the largest technical bottleneck in the project, much more so than the actual use of machine learning software to train the model. So I think that what's going to happen is that the predictive use cases are going to be part of the plan from the inception of an organization or of a new line of business. Instead of being post hoc, we'll put the hooks in place so that everything's planned around those potential. Once things are happening, there's enough operations and enough data has been accumulated from which to learn. It'll be much easier because the data will have been collected correctly. Yeah. So I think that that's a shift. So now let's see, trying to put your question in terms of generative. What generative is largely, most of its use cases you could call ad hoc, because it's kind of experimental. Like, I need to do some brainstorming, or I need to draft a new marketing material or letter to 100 customers or whatever. Thing spits out first drafts, and then you're a human. You do the prompting, you proofread the drafts that it's generated, you decide how to edit them. So, generative AI is much, much easier to use than predictive by definition, because anybody can just interact in English with it, or their language. On the other hand, it might be much, much harder to use well in terms of actually driving large scale enterprise value. Maybe, right? But it's kind of the wild, wild west. Try it out, see how it affects you, and what value you get from it depends on you, and depends on the particular context and what you're trying to use it for. It's certainly very valuable a lot of the time. One of the main feathers in its cap is to draft code, computer code, and that really can increase efficiency. You're seeing numbers out there, 30 to 60% efficiency improvement or something. And of course, again, it's really going to depend on the nature of what you're trying to program, what the task is, and who the programmer is, and et cetera. It really depends. So for lots of individual humans, it's going to become just a part of their toolkit, and people are going to adopt it differently from one person to the next. So it's just going to be part of the ecosystem and part of the culture and part of everyone's individual preferences. So, in that sense, maybe harder to track, right? Whereas predictive use cases and projects need to be centralized within the organization.
Got you. I think I have just one last question for you here. Kind of just to wrap this up a little bit, wanted to leave probably the startups that are listening us now, and probably small, medium enterprises that have stumbled upon this podcast, who might not necessarily have large data science teams. What could be pragmatic steps that they could put in place if they do not necessarily have the data science teams in place? Are there ways that you've seen, at least from practice, that you can deploy and utilize AI effectively without the need of kind of in-house large data science teams?
Yeah, you don't necessarily need, especially for early projects where you're trying to establish the potential value, you don't necessarily need that data scientist who's going to run the machine learning software in-house. In fact, as I mentioned a moment ago, that part of the project is a relatively small number of person hours. Whereas the data prep, which is not the rocket science part, although you definitely want to have consulting input from an expert who's had experience. So let me put it another way. Overall, you can conduct these projects with a relatively limited, you can control the costs. You can use external resources, typically in the form of a boutique consulting firm, in a way that's efficient. You don't have to have a whole team of data scientists in-house. They can consult in the literal sense of the word through the project, and then do the actual hands-on part for the model training. The idea of a citizen data scientist, I feel many of us feel, is sort of a fictional conceit. But you can do a lot without their doing every hands-on step, as long as they're providing some expert wisdom and direction for doing the data prep, defining the project in the first place, across the 6 steps. At step 5, the model training part, where they need to do the hands-on part, probably, at least aside you. But then even the model deployment, how do you integrate it? Their expert insight will help guide it, but it's something your engineers can do without being data scientists themselves.
It has been such an insightful chat, Eric. Really, really thank you so much for joining us today. And unfortunately, we've reached to the end of this episode. So thank you again for joining us.
Yeah, my pleasure, Tarek. Thanks so much for having me.
Reminder again for everybody who's listening, you'll see in the description all the links that will get you to reach out to Eric and to know all about his businesses. Remember to also leave your comments. Should you wish us to ask Eric any additional questions, feel free to put them down in the comment section. Do leave us a like, subscribe, and hit that bell icon. Till next episode, stay groundbreaking. This is Tarek signing off. Until then, thank you.